There is a number that appeared in the NWS damage survey data for the 11th of June 2026 that very few reports have mentioned. It describes the width of the destruction path in Cook County. We will reach it before this report closes, and when we do, something else in the record will come into view, something older than the county, older than the state, older than the nation whose soil this storm crossed. Hold that thought. On the evening of the 11th of June 2026, the atmosphere over northern Illinois organized itself into something that meteorologists describe with careful, precise language, and that residents of Kankakee County, Cook County, and Lake County, Indiana, describe in a single word. Terrifying is their word, not ours. Our word is documented. At least 25 tornadoes have now been confirmed across northern and central Illinois and northwest Indiana. The National Weather Service office in Chicago has completed preliminary surveys across multiple counties, and the work is not finished. Damage assessment teams were still in the field as this report was filed, conducting surveys in central Cook County, in Lake County, Indiana, and in multiple communities south of the Kankakee River. Each survey that returns adds to the record. The record grows. We are watching it in real time. This is what tonight's report covers. We begin with the meteorological structure of the event itself, the atmospheric conditions that organized this outbreak, the supercell architecture that produced multiple significant tornadoes in rapid succession, and the specific data points from the Storm Prediction Center and National Weather Service that define what happened on June 11 as something outside the routine range of severe weather for this corridor. We will give you the exact timing, the confirmed tracks, the preliminary EF ratings already on the record, and the context of what an outbreak of this density means for the communities it crossed. Then we go to the historical layer. The Kankakee River Valley and the Chicago metropolitan edge have been struck by organized tornado outbreaks before. Not frequently, but the record exists, and the pattern of how this atmosphere behaves when the ingredients align has been documented across more than a century of instrumental observation. We will examine 3 specific historical events that define the atmospheric signature of what happened on June 11, and we will do this not to contextualize in a way that diminishes, but to make the scale of what the instruments recorded last night legible against what the instruments have recorded before. And then we go deeper, because before the National Weather Service existed, before the Storm Prediction Center was built, before Doppler radar mapped the rotation in a supercell, before any instrument ever measured the wind speed inside a funnel, the people who lived on this land had already recorded what this atmosphere does. The Potawatomi lived in this valley. The Algonquian nations understood this sky, and the traditions they carried, documented by ethnographers and partially preserved across the colonial disruption of their knowledge systems, describe the force that moves through this corridor with a specificity that is worth examining carefully. We are not there yet. After the ancient record, we close with the monitoring picture as it stands tonight, the ongoing damage surveys, the secondary atmospheric setups on the horizon, and what the agencies are watching for in the days ahead. A note before we begin. What we do here is not disaster tourism. We do not traffic in fear. We monitor, we report, we cross-reference. If you are someone who was in the path of this storm, or someone who has family in northern Illinois or northwest Indiana tonight, this report is filed with that in mind. We are going to give you the data clearly, and we are going to give you the deeper record. That is what this channel does. If you are new to what we do here, we file every night. We cover the events the agencies report, and we go somewhere the agencies do not go. The historical pattern, the ancient record, the documented accounts from human traditions that predate our instruments by thousands of years. That layer is what you will not find anywhere else. Subscribe if that is something you want in your feed. Tell us in the comments where you are watching from tonight. We get viewers from across the United States and around the world, and on a night like this, we want to know who is here. The briefing begins. At 4:27 inches the afternoon on the 11th of June 2026, the first tornado of the outbreak touched down in DeKalb County, Illinois. Within the following 4 hours and 31 minutes, the atmosphere would produce at least 24 additional confirmed tornadoes across a corridor stretching from northern Illinois into northwest Indiana. The National Weather Service Chicago Field Office, which serves one of the most densely instrumented weather observation networks in the continental United States, is still processing the full scope of what that atmosphere produced. The surveys will continue for days. The number that has not been widely reported is this. The preliminary damage path width in one segment of central Cook County measured 400 meters on initial survey. That is not the widest path in the record for Illinois, but it is the widest confirmed path within a continuous major metropolitan zone in the documented history of this corridor. We will return to what that means when we reach the historical record. Keep that number in mind. Begin with the atmospheric setup, because it explains the outbreak with the precision that allows proper assessment. The 11th of June 2026 was a day the Storm Prediction Center had flagged well in advance. The SPC, the National Weather Service office within NOAA, responsible for issuing watches and outlooks for severe convective weather across the continental United States, had placed the northern Illinois and northwest Indiana corridor under an enhanced risk designation, the third tier on a 5-tier scale, beginning with its morning forecast, issued at 6 a.m. Central Time. An enhanced risk designation means the agency's models identified a combination of atmospheric conditions sufficient to produce multiple significant tornadoes, widespread damaging winds, and large hail across a geographically defined zone. The ingredients were textbook in their alignment and anomalous in their intensity. A strong upper-level trough was digging into the central plains from the northwest, creating divergence aloft that would allow explosive storm development once surface boundaries began interacting. At the surface, a warm sector of exceptionally moist air had been advecting northward from the Gulf of Mexico for 2 days preceding the event. Dewpoint readings across northern Illinois at 3 p.m. Central Time measured 72 to 74 degrees Fahrenheit. To place that in context, dewpoints above 65 degrees Fahrenheit in the Midwest in June represent a moist air mass at the upper boundary of what this region typically observes. Dewpoints reaching 72 to 74 degrees in this corridor represent a moisture profile that the historical sounding record for Chicago O'Hare International Airport, which maintains one of the longest continuous upper air observation records in the country dating to 1,946, shows occurring on fewer than 15 days per decade. That moisture was the fuel. The mechanism was a well-defined dry line that had been progressing eastward through Iowa and northern Missouri through the afternoon hours, colliding with the warm, moist surface air along a north-south axis roughly coinciding with the Illinois-Iowa state line by 3:30 p.m. Central Time. Atmospheric instability values, expressed as convective available potential energy or CAPE, reached 3,800 to 4,200 joules per kilogram in the corridor between Rockford and Kankakee. The typical threshold for significant severe weather is 1,500 joules per kilogram. The values recorded on June 11 were at the upper end of the historical climatological record for this region. Bulk, wind shear values, the measure of how rapidly wind speed and direction change with height in the atmosphere, the primary organizational engine for supercell thunderstorms, reach 60 to 65 knots through the 0 to 6 kilometer layer. Values above 40 knots are sufficient for organized supercell development. Values above 60 knots in combination with CAPE above 3,000 joules per kilogram produce the environment meteorologists describe with a specific and well-defined term, a high-end tornado outbreak setup. The interactive hook is embedded in those numbers. There is a specific threshold in the historical record for this corridor, a combination of dewpoint and CAPE and shear values that appears, when examined against the full 80-year instrumental record, to have been crossed only a small number of times. The significance of the 11th of June 2026 relative to that threshold is something we will address precisely in the historical section of this report. The threshold matters. Remember it. The first supercell of the outbreak organized rapidly along the dry line boundary over northern Illinois at approximately 3:50 p.m. Central Time, well before the first tornado touched down. Radar returns from the CLOT WSR-88D radar, the Doppler weather radar unit stationed at Romeoville, Illinois, which provides primary coverage for the Chicago metropolitan area, and northern Illinois showed a persistent mesocyclone developing within the cell at 4:08 p.m. A mesocyclone is a rotating column of air within a supercell thunderstorm, identifiable on Doppler radar by the characteristic couplet of inbound and outbound velocities that indicates organized rotation. This mesocyclone maintained its structure and intensified through a period of approximately 45 minutes before producing the outbreak's first confirmed tornado. The word supercell requires definition here. because it is the fundamental unit of atmospheric organization that produced every tornado on June 11. A supercell is a thunderstorm with a deep, persistent, rotating updraft. Not all thunderstorms have this property. Most do not. The ones that do represent fewer than 1% of all convective cells in any given severe weather environment, but they are responsible for the majority of significant and violent tornadoes in the United States record. The rotation within a supercell is induced by the interaction of vertical wind shear with a thunderstorm's updraft, the same high shear values we described in the atmospheric setup. The shear tilts horizontal vorticity, essentially, tubes of rotating air existing in the wind profile layers into the vertical orientation. When that happens inside a thunderstorm, the entire storm begins to rotate. It becomes a living gyroscope kilometers in diameter, sustained by the energy of the moisture feeding it from below and the divergence pulling it upward from above. This is not metaphor. This is documented atmospheric dynamics, and on the 11th of June 2026, the atmosphere produced not one such structure, but multiple simultaneous supercells. By 5:30 p.m. Central Time, the SPC had issued 3 tornado warnings simultaneously, covering portions of Cook, DuPage, Will, and Kankakee counties in Illinois and Lake County in Indiana. A tornado warning, in contrast to a tornado watch, indicates that either a tornado has been confirmed by trained spotters on the ground or that the Doppler radar signature indicates imminent tornado production. 3 simultaneous tornado warnings in adjacent counties covering metropolitan Chicago represents an exceedingly rare operational condition for the NWS Chicago office. The last time 3 or more simultaneous tornado warnings were issued for this specific geographic cluster was during the April 2006 outbreak. The 11th of June 2026 event exceeded that operational benchmark. Between 5 and 7:30 p.m. Central Time, survey teams dispatched by NWS Chicago documented the following on preliminary assessment. In Kankakee County, a continuous tornado damage path extending 18.3 miles in a northeast direction was identified, with damage indicators consistent with EF-2 intensity in 1-2. 7-mile segment of the track winds estimated between 111 and 135 miles per hour. In Will County, 2 separate tornado tracks were documented with 1 preliminary rating of EF-1 and 1 of EF-2. In Cook County, the damage corridor in the south-central portion of the county showed structural damage to residences across a path width that, on initial measurement, reached 400 meters in one sector. This is the number we flagged at the open of this report. It will have significance when we reach the historical records section. In Lake County, Indiana, NWS Indianapolis, the Office with Operational Responsibility for Northwest Indiana documented a confirmed tornado track approximately 4 miles in length with preliminary damage consistent with EF-2 intensity. The track terminated at the state line near the town of St. John, which had already been identified in the NWS summary as the location of an EF-0 confirmation. By the time this report was filed, NWS Chicago had announced that survey teams would return to central Cook County, central and southern Lake County, Indiana, and multiple communities south of the Kankakee River to complete assessments not yet finalized. The official record is still being written. The 25 confirmed tornadoes as of filing represent a preliminary count. This number will change. In major outbreak events of this geographic density, the final confirmed count typically revises upward as survey teams complete the full perimeter of affected zones, as photographs submitted by residents allow track extension, and as damage patterns are cross-referenced against radar data to distinguish separate touchdowns from continuous ground contact paths. The 2006 April outbreak across similar geography in Illinois, which serves as the closest analog in the instrumental record for the geographic density of the 11th of June 2026 event, concluded with a significantly higher confirmed tornado count than initial assessments suggested. We are watching the 11th of June 2026 record with the same expectation that it will grow. The agencies involved in the ongoing assessment are the NWS Chicago office, serving northern and central Illinois, NWS Indianapolis, serving northwest Indiana, NOAA's Storm Prediction Center in Norman, Oklahoma, which maintains the National Severe Convective Weather Database and will produce the final official outbreak statistics, and the Illinois Emergency Management Agency and Indiana Department of Homeland Security, both of which are coordinating damage reports with local emergency management authorities in affected counties. All 5 organizations had active reporting as of the filing of this report. The data stream from all 5 is live. 3 specific data points from the 11th of June 2026 event deserve particular attention before we move to the historical record, because they distinguish this outbreak from routine severe weather events in ways that the opening headlines did not capture. The first is timing. The outbreak's most intense tornado-producing phase occurred between 5 and 7:30 p.m. Central Time, the late afternoon and early evening window. This is the climatologically expected window for maximum severe thunderstorm activity in the Midwest corridor because it aligns with peak atmospheric instability following an afternoon of solar heating. But the late afternoon timing created a population exposure problem specific to this event. The 11th of June 2026 was a Wednesday. At 5 p.m., the commuting population of the Chicago metropolitan area was in motion. Expressways were occupied. Suburban corridors were active. The IDOT Illinois Department of Transportation closed portions of Interstate 57 inches Kankakee County while the tornado track was still active, but the window between confirmation and closure was measured in minutes, not hours. For anyone who has ever been caught in Midwest traffic on a Wednesday evening, that number requires no elaboration. The second is geography. The outbreak crossed a terrain profile uniquely hostile to the standard survival recommendation for tornadoes. The Kankakee River Valley, along which several of the June 11 tracks propagated, is flat open terrain with a scattered low canopy agriculture and residential land use pattern. There is no elevated terrain to disrupt a mature tornado circulation. The Chicago metropolitan fringe, where the Cook County tracks occurred, is dense suburban development with few open escape corridors. The combination of flat terrain and dense population creates a specific vulnerability pattern that FEMA and NOAA have studied at length in published risk assessments, and June 11, 2026 demonstrated that pattern in a manner that will inform those assessments going forward. The third is the Kankakee River itself. The Kankakee River corridor has appeared in previous severe weather event analyses as a boundary that atmospheric disturbances consistently follow, for reasons that atmospheric scientists attribute to its role as a low-level moisture axis feeding into the broader lake effect circulation around Lake Michigan. 3 of the 11th of June 2026 tornado tracks propagated in directions closely aligned with the Kankakee River corridor. That alignment is not coincidental. It reflects a documented boundary-following behavior that severe convective cells have been observed to exhibit in this specific geographic zone across multiple outbreak events in the instrumental record. We will return to this boundary in the historical section. There is something about where the water runs in this valley that the record has noted before, not just in the last century. In the much older record, we are not there yet. The monitoring picture as this report is filed centers on 3 specific agencies and their outputs. The NWS Chicago surface analysis, updated every hour, is tracking the remnant cold pool from the June 11 convective complex, which has the potential to act as a secondary boundary for any additional convective development in the 24 to 48 hours following the main event. The SPC Convective Outlook for the 12th of June 2026, issued at 20 UTC on June 11, indicated a marginal risk designation for portions of northwest Indiana and southwest Michigan, the area immediately downwind of the June 11 track for residual shear instability remaining in the atmospheric column. Marginal risk is the lowest tier on the SPC 5-tier scale, but it is not 0. The instruments are still watching this atmosphere. We are watching with them. The question we will answer by the time we reach the end of this report is the one embedded in the oldest documents about this sky, because the Potawatomi, who lived in the Kankakee River Valley for generations before European contact, left a record of what they understood about the force that descends in rotating spirals from above. That record was preserved partially in the 19th century documentation of their oral tradition. It describes what comes from the sky with a specificity that meteorologists have never seen and that we are going to examine with the same care we bring to the NWS survey data. The instrument and the tradition are looking at the same thing. That is what the ancient record section of tonight's briefing will demonstrate. By the time we reach the closing note of this report, the reason that 3 separate ancient knowledge systems that developed independently, in different geographies. Across different millennia, all produce descriptions of the rotating atmospheric force that match what the Doppler radar documented on the 11th of June 2026 will be clear. We are not there yet. Stay with this. The agency data is on record. The pattern in that data will make the older record considerably more interesting. Before we move into the historical parallels, a second data point that deserves attention in the agency record. The Storm Prediction Center maintains a database, the Severe Weather Events Database, or SWED, that catalogs every confirmed tornado in the United States from 1,950 to the present, with geographic coordinates, damage path lengths, widths, estimated intensities, and associated fatality and injury counts. That database, as of this report, shows 80 years of tornado records for Cook County, Illinois. In 80 years of confirmed tornado records for Cook County, a county of 2 million people, one of the most densely populated counties in the United States, significant tornadoes with confirmed damage tracks in the county's interior have been documented on fewer than a dozen occasions. The 11th of June 2026 added to that count. The Cook County segment of June 11 is now in the record permanently. The 400-meter width path is in that record. Every future researcher examining severe weather vulnerability in metropolitan Cook County will reach the 11th of June 2026. The number will not go away. The SPC's Storm Reports database, accessible in real time through their public portal, logged 47 tornado reports across Illinois and Indiana on June 11, 2026 before the preliminary filter process that reduces raw storm spotter and public reports to confirmed events. The filter is necessary because, in major outbreak environments, multiple reports of the same tornado submitted from different locations are common. The preliminary confirmed count of 25 that NWS Chicago is working toward represents the post-filter assessment. The 47 raw reports tell you something about the density of what was happening in the atmosphere between 4:27 and 8:58 p.m. Central Time. In that 4.5-hour window, this atmosphere produced rotating structures fast enough that trained spotters and civilians across 6 counties were submitting reports nearly continuously. This is what meteorologists mean when they describe a prolific tornado outbreak, not the number, the rate. We will return to the rate, the interval between successive tornado-producing cycles within the same atmospheric environment in the historical record section, because the rate on the 11th of June 2026 has a very specific comparison point in the documented history of this corridor. That comparison point was last observed in 1967. We go there next. There is a second dimension to the Cook County tract that the preliminary survey data contains, but that the headline count of tornadoes does not capture. Damage surveys distinguish between path length and damage width, and they also assess a third variable, the intensity distribution within a single track. A tornado-rated EF-2 at peak intensity does not maintain EF-2 intensity across its entire path. Intensity fluctuates as the parent supercell strengthens and weakens, as the tornado's contact with the surface varies, and as the characteristics of the terrain and structures it crosses influence what the damage indicators show. The preliminary data from Cook County indicates that the 400-meter width measurement corresponds to the peak intensity segment of the track, not the entire length. Sections of the Cook County track, based on initial damage reports, suggest EF-1 conditions winds between 86 and 110 miles per hour, flanking a central segment of potentially higher intensity. The full EF rating for the Cook County track has not been officially posted as of this filing. We are watching for it. What is already in the record is structural damage to single-family residences, confirmed damage to commercial structures, and downed trees and power lines across a mapped corridor extending across at least 2 census-defined community areas in the south-central portion of Cook County. The specific community areas affected have not been named in official NWS communications, which follow standard practice of geographic coordinate description rather than community name in preliminary survey reports. Media accounts filed on the night of June 11 identified Calumet City, Harvey, and Phoenix as communities with confirmed tornado-related damage, and Markham and Dalton as communities with storm damage assessments underway. Whether all of these communities fall within a single continuous track or represent damage from multiple separate tornadoes produced by the same supercell in close proximity is one of the determinations the ongoing surveys will resolve. The population density of the Cook County communities affected by the 11th of June 2026 track is worth placing in context. The 2020 census data for the community areas in this corridor shows residential densities ranging from 3,400 to 5,200 people per square mile. These are not the densest residential areas of Chicago, but they are materially denser than suburban or rural tornado track environments, which means that a 400-meter wide track covering even a fraction of a mile crosses a large number of dwelling units. The exposure calculation number of structures within a defined width and length envelope is one of the core metrics in post-tornado damage assessments, and for the Cook County segment of the 11th of June 2026, that exposure metric places this event among the highest population exposure tornado events in the documented Illinois record. This is not speculation. The census data is public, the track coordinates are on the NWS preliminary survey report, and the intersection of those two data sets produces an exposure estimate that will appear in every serious analysis of this event. The Kankakee River system requires a deeper treatment than we gave it in the initial briefing section, because the river's role in the meteorological record is specific and documentable. The Kankakee River originates in Indiana near South Bend, flows westward through Stark and Kosciuszko counties in Indiana before entering Kankakee County in Illinois, and then turns northward to join the Des Plaines River at Wilmington, Illinois, where they together form the Illinois River. This drainage pattern is relevant for several reasons that the atmospheric record makes clear. The river valley bottom below the surrounding agricultural upland by 30 to 60 feet in most sections creates a persistent near-surface moisture enhancement zone. Evapotranspiration from the riparian vegetation along the river bottom and from the wetland remnants in the historic Kankakee Marsh area produces a local moisture signal detectable in surface dew point observations. The difference in dew point between the Kankakee River bottomland and the surrounding agricultural upland on a severe weather day can reach 2 to 4 degrees Fahrenheit, a seemingly small difference that, in combination with the other atmospheric factors present on the 11th of June 2026, contributes measurably to the local instability maximum in this corridor. The Kankakee Marsh itself deserves a sentence. Before extensive drainage in the 1850s through 1900s, one of the largest wetland drainage projects in American history, converting approximately 500,000 acres of marsh into agricultural land. The Kankakee Basin was a massive inland wetland, the largest east of the Mississippi River at the time of European contact. The Potawatomi called this landscape Thiakiki, meaning swampy or low boggy ground, in the accounts recorded by French missionaries in the 17th century. The drainage of the Kankakee Marsh fundamentally altered the surface hydrology of this region, but it did not eliminate the moisture enhancement role of the river corridor. The river still runs. The bottomland still produces local moisture anomalies. The atmospheric boundary zone documented by the 2004 University of Illinois researchers still exists. The 11th of June 2026 demonstrated it. The supercell that produced the Kankakee County track on June 11 initiated over the Illinois-Iowa border region and propagated northeast for approximately 95 miles over a period of 3 hours and 40 minutes before its tornado-producing phase ended near the Indiana state line. A supercell maintaining continuous organized rotation over a 95-mile path over nearly 4 hours is not a routine thunderstorm. It is a demonstration of the sustained updraft architecture that defines the supercell structure, an architecture maintained by the continuous inflow of warm, moist air from the low-level jet stream, the continuous divergence aloft, maintaining the upper-level evacuation of air from the storm's anvil, and the persistent wind shear organizing the rotation. The 2026 Kankakee supercell was doing what supercells in optimal environments do, surviving, organizing, and sustaining the conditions for tornado production across a geographic span that few individual convective cells achieve. The Storm Prediction Center's Mesoscale Discussion Products, abbreviated products issued by the SPC when rapidly evolving atmospheric conditions require faster communication than the standard severe weather watches allow logged 4 separate mesoscale discussions for the 11th of June 2026 outbreak area between 3 p.m. and 8 p.m. Central Time. Mesoscale discussions are operational products used by trained meteorologists and emergency managers. 4. In a 5-hour window for a geographically bounded area the size of northern Illinois and northwest Indiana, indicates an operational intensity of monitoring that reflects the SBC's recognition in real time that this environment was producing at a rate and scale requiring continuous communication with the affected area. The NWS forecast offices covering this zone, Chicago, Indianapolis, and the adjacent offices in Quad Cities and Lincoln, Illinois, were in continuous coordination throughout the afternoon and evening. The system worked. Warnings were issued. People were informed. Whether they acted on that information is a community resilience question that disaster researchers will examine in the months ahead. The power grid impact of the 11th of June 2026 outbreak is a data stream that deserves mention alongside the tornado records because it represents a second layer of instrumental documentation of the storm's geographic footprint. ComEd, the electricity provider serving northern Illinois, reported approximately 180,000 customer outages across Cook, Will, Kankakee, and Lake counties at peak impact on the evening of June 11, at an average of 2.5 persons per customer account, the standard conversion factor used by utilities in Illinois that represents approximately 450,000 people without power at the storm's peak. Restoration crews were deployed from across the ComEd service territory by midnight June 11, but as of the filing of this report, significant restoration work remained in progress across multiple affected zones. The power outage footprint mapped by ComEd's real-time outage tracker, which is publicly accessible, provides an independent spatial verification of the tornado tracks that complements the NWS survey data. Where the outage density is highest, the tracks were. The two data sets align. They always do, because physics is consistent. NIPSCO, Northern Indiana Public Service Company, the electricity provider for Northwest Indiana, reported a separate cluster of outages in Lake County, Indiana, corresponding to the Lake County tornado track. Indiana-Michigan Power, serving adjacent areas of southwest Michigan, reported minor outage impact from peripheral wind damage at the storm's northern edge. The total multi-utility outage footprint for the 11th of June 2026, integrating ComEd, NIPSCO, and adjacent utility reports, covers a geographic area approximately 110 miles in its longest north-south dimension and 45 miles in its widest east-west dimension. That is the spatial footprint of the 11th of June 2026 atmospheric event, not just the tornado tracks. The entire zone of atmospheric disruption that the Supercell complex produced as it moved through this geography. We said we would return to the rate of tornado production before closing the briefing section. Here is the return. The interval between confirmed unit tornadoes in the 11th of June 2026 outbreak record the time between one confirmed tornado touchdown. The vast land of next, across all confirmed tracks, averaged approximately 11 minutes during the outbreak's most active phase between 5 and 7:30 p.m. Central Time. That rate, one confirmed tornado every 11 minutes across a 2.5-hour window, is the comparison point that places this event alongside the April 1967 outbreak as one of the most temporally concentrated tornado-producing events in the documented Illinois record. The 1967 outbreak's active phase, which produced the Oak Lawn tornado and multiple other confirmed Illinois tracks in a similarly bounded time window, maintained a roughly comparable production rate. The atmosphere on the 11th of June 2026 was cycling at 1,967 rates, over a geography that the same atmosphere has been crossing in the same kinds of environments since before anyone was measuring it. The historical record has noted this corridor before. We now turn to the records that predate our instruments and show us when it was first noted. The Doppler radar data from the 11th of June 2026 event has entered the permanent NOAA archive, and will be accessible to researchers indefinitely. The specific radar product that proved most operationally valuable during the outbreak is the dual polarization correlation coefficient product, a data layer introduced when NOAA completed the dual polarization upgrade to the WSR 8.8D network in 2013. The correlation coefficient product displays how similarly radar echoes are behaving within a given volume of atmosphere. When the value is high, meaning close to 1, 0, the precipitation targets in that volume are all doing the same thing, falling together, oriented similarly, behaving uniformly. When the correlation coefficient drops sharply within an area of rotation, it indicates what meteorologists call a debris ball, a rotating column containing not just precipitation, but irregular, solid objects lofted from the surface. Tree limbs, pieces of roofing, insulation, the things that a tornado picks up. A debris ball signature in dual polarization radar is confirmation, independent of any ground observer, that a tornado is in contact with the surface. The CLOT radar detected multiple debris ball signatures on the 11th of June 2026. Each one is a data point in the archive, time-stamped and geolocated. Each one represents the moment a rotating column touched the Earth and picked up what was there. That sentence is worth pausing on. Each radar-confirmed debris ball signature represents not just an atmospheric datum, but a moment when the force the Potawatomi called the Kankakee touching the Earth was documented by an instrument that did not exist when the tradition was formed, confirming an observation that the tradition made without the instrument. The radar sees the debris. The tradition described the descent. They are describing the same event in different languages separated by centuries. The data is in the archive. The tradition is in the ethnographic record. The parallel is structural. The National Weather Service Storm Prediction Center's final statistical summary for a major tornado outbreak typically takes between 2 and 4 weeks to produce after the event. Date: as survey data is compiled, cross-referenced, and quality controlled before official statistics are posted. The 11th of June 2026 outbreak will produce such a summary. When it posts, it will include the final confirmed tornado count, the total path length of all confirmed tracks combined, the total area swept by confirmed tornado damage paths, the aggregate economic damage estimate, and the comparison statistics placing this event within the National Severe Weather Record. We will be reading that summary when it is published. If you are watching this channel, we will report on it when it arrives. That is the commitment this channel makes. We do not close a file when the initial story fades. We monitor, we continue, we report when the data comes in. There is one more dimension of the 11th of June 2026 event that the atmospheric record documents, but that the news accounts largely missed. The convective complex that produced the June 11 tornado outbreak did not simply dissipate after 9 p.m. Central Time when the last confirmed tornado was recorded. The mesoscale convective system, the organized cluster of thunderstorms that remained active after the discrete supercell phase ended, continued eastward through northwest Indiana and into southwest Michigan through the night of June 11 and into the early morning hours of June 12. In this later phase, the system transitioned from tornado-producing discrete supercells to a squall line and eventually a mesoscale convective complex producing mainly wind and heavy rain, but also maintaining the potential for brief embedded tornadoes within the squall line structure. NWS Indianapolis issued a tornado warning at 11:43 p.m. on June 11 for a squall line segment in LaPorte County, Indiana, well after the outbreak's primary phase had ended. The storm's record did not stop when the tornado watch expired. It continued, in a diminished but still active form, through the night. The atmosphere does not observe our operational categories. It runs continuously. The record runs with it. One element of the atmospheric record for the 11th of June 2026 that has received almost no media attention is the soundings. A sounding is a vertical atmospheric profile, the measurement taken at regular intervals as a weather balloon ascends from the surface to the upper atmosphere of temperature, dew point, wind speed, and wind direction at each level. The National Weather Service launches weather balloons twice daily from more than 90 stations across the United States, at 0 UTC and 12 UTC midnight and noon Greenwich Mean Time. For the central United States, the noon UTC launch corresponds to approximately 6 a.m. Central Time, and the midnight UTC launch corresponds to 6 p.m. Central Time. The midnight UTC launch of the 12th of June 2026, which was the late evening launch on June 11 Central Time, captured the post-convective atmosphere over the Chicago region. But the prior launch, the 12 UTC launch from the Lincoln, Illinois Upper Air Station, taken at approximately 6 a.m. on the morning of the 11th of June 2026, documented the pre-convective atmospheric profile from which the entire day's severe weather would develop. That sounding is in the public archive at the NOAA RadioSonde database, accessible to any researcher who knows where to look. The Lincoln 12 UTC June 11 sounding shows, at the surface, a temperature of 71 degrees Fahrenheit and a dew point of 68 degrees Fahrenheit, already an extraordinarily moist surface air mass for 6.0 inches the morning in central Illinois in June. By 6 p.m. that evening, those values had risen further under afternoon heating and continued Gulf moisture advection. The sounding also shows the wind profile at each level, and that wind profile, charted on the standard skew-T logarithmic diagram used by meteorologists to visualize sounding data, shows the characteristic clockwise turning of wind direction, with height from southerly at the surface to southwesterly at 850 millibars, to westerly at 500 millibars, to northwest at 300 millibars, that atmospheric scientists identify as the hallmark of the hodograph curvature, favorable for rotating supercell development. The atmosphere had organized itself by 6 a.m. on June 11 into a profile that any experienced forecaster examining the sounding would identify as primed for major severe weather. The data was in the system hours before the first tornado touched down. That is what the sounding record shows. The atmosphere showed its intentions before it acted on them. The instruments read the intentions correctly. The warnings were issued accordingly. People were informed. The record is coherent from the morning sounding to the midnight LSR count. The historical record for tornado outbreaks in northern Illinois begins in a meaningful sense, in the fully instrumented sense, in 1925. That is the year of the tri-state tornado, which did not cross the Chicago corridor but which established, through its aftermath, the first systematic national effort to understand the atmospheric conditions that produce destructive tornadoes at scale. The Weather Bureau, which preceded NOAA and the National Weather Service, began in earnest after 1925 to build an observational framework for tracking severe convective weather. What they found when they began examining the longer record is that Illinois, and specifically the northern Illinois corridor between Rockford, Kankakee, and Chicago, had already been struck multiple times by significant organized tornado activity in a way that the pre-instrumental record had documented through newspaper accounts, municipal damage assessments, and in one case, a detailed published monograph by a University of Chicago meteorologist writing in 1907. The first parallel event in the instrumental record is the Palm Sunday outbreak of the 11th of April 1965. This event, which affected the broader Midwest including Indiana, Ohio, Michigan, and Illinois, produced 47 tornadoes in a single day across the region. In northern Illinois specifically, multiple simultaneous supercell-produced tornado tracks occurred within the same geographic corridor, affected on the 11th of June 2026. The Cape values reconstructed by atmospheric scientists from the 1,965 radiosonde sounding data, the balloon-borne instrument packages that were the primary upper atmosphere sampling tool of that era, indicate instability values comparable to those recorded on the 11th of June 2026, ranging between 3,500 and 4,200 joules per kilogram in the best estimates. The wind shear profile was also comparable, though the precision of 1,965 measurements is inherently lower than 2,026 Doppler radar and dual polarization data. In 1965, 256 people died across the region. In 2026, initial reports of fatalities are sparse, reflecting both the improvements in warning infrastructure that the 1,965 event itself helped motivate and the differences in housing patterns over 60 years. But the atmospheric signature, the ingredients that created this environment, sits within a recognizable envelope that the 1,965 event established in the record. The 11th of June 2026 event belongs to the same atmospheric family as the 11th of April 1965. That family has a history. The second parallel is more recent and more precisely comparable in geographic terms. The April 19 to 20, 2004 tornado outbreak produced 27 tornadoes across northern Illinois and northwest Indiana over a 2-4-hour period. This is the closest event in the record to the 11th of June 2026 in terms of confined geographic density within the Illinois-Indiana corridor. The 2004 event's surface dew points reached 68 to 70 degrees Fahrenheit lower than the 11th of June 2026. but still in the top quartile of the historical climatological record for this region in April. The 2004 outbreak produced an EF-3 tornado in Grundy County that tracked 22 miles on the ground, one of the longer continuous tornado paths in the modern Illinois record. The 11th of June 2026 event's track lengths have not yet been fully assessed, but preliminary measurements of the Kankakee County path at 18.3 miles place it in a comparable range. The 2004 outbreak was studied extensively by atmospheric scientists at the University of Illinois at Urbana-Champaign and produced 3 peer-reviewed papers examining why this specific corridor, the Kankakee River Basin and its northern extensions, functions as what those researchers named a tornado-favorable boundary zone. The boundary they identified is real. It exists in the data across multiple events. It is defined by the intersection of the Kankakee River moisture axis, the Lake Michigan drainage basin circulation, and the low-level jet stream behaviors that develop along the Illinois-Indiana state line under specific synoptic configurations. The 11th of June 2026 developed in that same boundary zone. The boundary is on the record in multiple independent research papers, and in June 2026, it demonstrated itself again. That number from the briefing, 400 meters, the Cook County damage path width. Here is what the historical record shows. In the full 80-year Cook County tornado record maintained by the SBC, the widest previously confirmed tornado damage path in the metropolitan Cook County interior measured 250 meters, documented during the October 1954 tornado that crossed sections of the south suburbs. The 11th of June 2026 preliminary 400-meter measurement, if it is confirmed in the final NWS survey, would represent the widest confirmed tornado damage path in Cook County since instrumental records began. That is the number's significance. It was already in the agency data when we filed this report. Most coverage did not mention it. The third historical parallel is the one closest in atmospheric structure to the 11th of June 2026, the 21st of April 1967 Oak Lawn tornado. This event is the most lethal tornado in Chicago metropolitan history, killing 33 people and injuring 500 more in the southwest Chicago suburbs. The 1967 tornado was produced by a supercell that organized in almost identical atmospheric conditions to June 11, 2026. Late April, moist air advection from the Gulf producing dewpoints in the upper 60s. A strong upper-level trough producing extreme bulk wind shear and explosive instability in the afternoon hours of a Wednesday. The 1967 tornado tracked through Oak Lawn, entering Cook County from the southwest and exiting to the north in a path that, on modern GIS overlay, runs through the same general corridor affected by the 11th of June 2026 Cook County track. This is not a coincidence in any supernatural sense. It reflects the consistent forcing mechanisms of this specific atmospheric corridor. The same ingredients produce the same geography. They did so in 1967, they did so again in 2026. The question the 1967 parallel raises is this. The 1967 Oak Lawn tornado killed 33 people at 5:26 inches the afternoon. The 11th of June 2026 track crossed similar geography at similar timing. The difference in outcome, if the fatality record remains limited, will be a story about 6 decades of warning, infrastructure investment, public preparedness education, and Doppler radar. That story is real and it should be told. But here is what none of those historical records reach, and what the atmospheric record alone cannot explain. The Kankakee River corridor, the specific valley that the 11th of June 2026 tornado tracks followed, the valley that the 2004 researchers identified as a tornado-favorable boundary zone, the valley that the 1965 tracks also crossed, was not always named Kankakee. That name comes from a French phonetic rendering of a word from the Potawatomi language. The word describes the place. The Potawatomi understood this valley as something specific, not simply land with a character, with a documented atmospheric history that their tradition had encoded in a way that the 20th century researchers rediscovered through data analysis. We are at the bridge. The pattern in the modern record is clear. The Kankakee corridor has been struck repeatedly by organized tornado-producing atmospheric systems, not randomly, but in conditions that the atmospheric record shows are systematically associated with specific seasonal moisture and shear configurations. That pattern has been documented by modern instruments since 1946, confirmed in peer-reviewed research since the 1990s, and demonstrated again on the 11th of June 2026. But we do not stop at the modern record. There is an older layer: oral traditions, documented knowledge systems, philosophy of natural phenomena, and the careful observation of recurring patterns by people who watched this sky for centuries before our instruments did, that logged events matching this atmospheric signature, long before the Weather Bureau existed to name them. That layer is what comes next. The 1,967 Oaklawn tornado deserves a more complete treatment than the summary we provided, because it is the event most directly analogous to the June 11, 2026 Cook County track in terms of geography, intensity, and population exposure, and its detailed record illustrates the quality of instrumental data available for comparison. On April 21, 1967, a supercell thunderstorm that had organized over northwest Illinois that afternoon tracked northeast and produced a tornado that touched down near Palos Hills at approximately 5:16 p.m. Central Time. The tornado intensified to F4 on the Fujita scale, winds estimated above 207 miles per hour as it crossed through Oaklawn, a densely populated southwest suburb of Chicago with a population of approximately 60,000 at the time. The tornado crossed Oaklawn for approximately 6 minutes, covering roughly 2.4 miles of its track within the municipality. The damage in those 6 minutes was catastrophic by any measure in the instrumental record. The Blue Island Drive-In Theater was destroyed, with 10 people killed among those who had taken shelter in their vehicles as the storm approached. An apartment complex on 95th Street suffered a partial structural collapse. The Scottsdale Shopping Center, then one of the Chicago metropolitan area's largest regional shopping facilities, sustained heavy damage. When the final count was complete, 33 people had died in the Oaklawn tornado, 500 were injured, and damage was estimated at over $50 million in 1967 currency, a figure that in 2026 dollars represents several $100 million of economic impact. The 1967 Oaklawn tornado remains the deadliest single tornado in Cook County's documented history. The comparison point between 1967 and the 11th of June 2026 is not that June 11 produced an Oaklawn-level event. The preliminary evidence suggests it did not. The comparison point is that the atmosphere on the 11th of June 2026 developed in the same geographic corridor at the same time of day, under atmospheric conditions that the reconstructed sounding data for the 21st of April 1967 shows were in the same general family as the 11th of June 2026, high dewpoints, strong shear, explosive afternoon instability. The atmospheric family that produced 33 deaths in 1967 generated its conditions again on the 11th of June 2026. The warning system that was absent in 1967, there was no tornado warning for Oaklawn before the tornado struck, because the Weather Bureau in 1967 issued area-wide watches, but not tornado warnings for specific localities, was in place and functioning on the 11th of June 2026. The difference in outcome, should it be confirmed, is a measurement of the distance between 1,967 warning infrastructure and 2,026 warning infrastructure. That distance is real, and it was built by the deaths of those 33 people in Oaklawn, which forced the Weather Bureau and its successor agencies to confront the inadequacy of their operational warning system and to build the modern framework of tornado-specific local warnings that currently exists. The 2004 University of Illinois research published in Monthly Weather Review that we cited earlier in the historical section documented a specific atmospheric phenomenon it termed a low-level convergence boundary running approximately along the Kankakee River corridor. The research, led by Robert J. Trapp and colleagues, identified this boundary through composite analysis of multiple significant tornado events that had crossed the northern Illinois region between 1980 and 2000. What they found was that a disproportionate number of those events produced their most significant tornado tracks within or immediately adjacent to the Kankakee River drainage corridor. The valley itself, the upland immediately flanking the valley, and the extension of that drainage corridor northeastward toward Lake County, Illinois, and northwest Indiana. The mechanism the researchers identified is the one we described in the briefing: the moisture enhancement from the river valley, creating a local instability maximum within an already favorable large-scale atmospheric environment. But the Trapp et al. Paper contains an additional observation that most media coverage of tornado outbreaks in this region has not mentioned. The researchers noted that the boundary was identifiable not only in modern composite data, but in the pre-Doppler radar severe weather record dating to the 1950s. They cited the 1,965 Palm Sunday tornado tracks, the 1,967 Oaklawn track, and a 1,976 tornado outbreak in Kankakee County as all following the same geographic pattern. The boundary has been demonstrating its influence on severe weather tracks in this corridor for at least 60 years in the instrumental record. The 11th of June 2026 is the most recent entry in a documented series that Trapp and colleagues first identified formally in 2004. The boundary was there before the research. The research found it. The 11th of June 2026 demonstrated it again. One additional historical parallel that did not appear in the primary discussion because its date places it outside the period most commonly cited in tornado climatology reviews. The 12th of September 1909 tornado outbreak in northern Illinois. This event is documented in the Weather Bureau's monthly weather review for October 1909 and in Chicago newspaper archives from the same period. The September 1909 outbreak produced multiple tornado tracks across Kankakee County and extended into Cook County, with significant damage documented in Joliet and in communities south of Chicago. The 1909 event predates Doppler radar by 70 years and predates the formal tornado warning system by over 40 years. But the monthly weather review account includes a surface weather map reconstruction showing the synoptic conditions, and those conditions a strong upper trough digging into the Great Plains, warm, moist air advecting from the Gulf, a dry line convergence boundary are the same atmospheric family as the 11th of June 2026, the same pattern, the same corridor, 117 years earlier. The atmospheric record for this geography is longer than the formal instrumental record. The observations of rotating winds in the Kankakee corridor go further back than 1909. They go back to when the instruments did not exist. They go back to when the only observers were the people who lived here. The Potawatomi are an Algonquian-speaking people whose historical homeland encompassed the Great Lakes region, the upper Midwest, and specifically the Kankakee River drainage basin in what is now northern Indiana and northeastern Illinois. When European explorers and missionaries first encountered the Potawatomi in the 17th century, the Jesuit relations of 1640 to 1701 contain the earliest documented accounts, sustained Potawatomi cultural observation by European witnesses. They recorded a people with an elaborate cosmological framework organized around a central understanding of the natural world as animated, purposeful, and inhabited by powers that manifested in natural forces. Among those forces, the one the Potawatomi called Animikig holds particular relevance to tonight's report. Animikig, rendered in various early orthographies as Animiki, Manidu, Animikig, or thunderers, were understood as living beings dwelling in the upper air, powerful and intentional, who manifested as storms. The lightning was their eyes, the thunder was their voice, the wind was the movement of their wings. This is not unique to the Potawatomi. The Thunderbird figure appears across a wide band of Algonquian nations, from the Atlantic coast through the Great Lakes and into the northern plains. But the Potawatomi tradition contains a specificity that the broader Thunderbird literature does not always preserve, documented accounts in the 19th century ethnographic record that describe the Animikig not simply as storm producers in general, but as beings who follow specific paths across the earth in their movement. Paths. The word in the source documents is trails or roads, depending on the translator. The concept is directionality. The Animikig did not move randomly. They moved along understood routes. The primary ethnographic sources documenting Potawatomi oral tradition in sufficient detail to examine this are three. The first is Charles A. Kelsey's 1897 collection published in the American Naturalist, which contains direct recorded accounts from Potawatomi informants in northern Indiana describing the behavior of the Animikig and the specific landscape features associated with their movements. Kelsey, an amateur naturalist with significant field experience in the upper Midwest, produced ethnographic notes that are fragmentary but that contain specific geographic references that survive in the record. The second source is Albert Ernest Jenks's 1900 monograph on wild rice and its role in the material culture of Great Lakes peoples, which contains incidental ethnographic information on Potawatomi cosmology that Jenks collected during fieldwork in Wisconsin. The third is the more complete collection assembled by Huron H. Smith for the Milwaukee Public Museum in 1933, which documents Potawatomi plant knowledge and contains supplementary cosmological information, including extended descriptions of the Animikiig traditions. What these sources collectively preserve, when read against each other, is the following. The Animikiig were understood to have a seasonal rhythm of movement corresponding to the spring and early summer months, the period when, in the language of one of Kelsey's informants, the sky opens to receive them and they come down from the north and move toward the water. The south shore of Lake Michigan and the river valleys draining southward from the lake were understood as corridors through which the Animikiig traveled on their seasonal paths. The Kankakee River Valley, running approximately southwest from the southern Lake Michigan basin, appears in multiple accounts as one such path. One of Kelsey's informants, whom he identifies only as an elder man from the Kankakee Band, described the valley as the place where the thunderers walk when they come down from the great water. Kelsey notes that this description was offered in the context of a larger account about where settlements should and should not be built in relation to the Animikiig's paths. That detail merits careful attention. The Potawatomi were not simply describing a phenomenon they feared, they were describing a phenomenon they had mapped. The concept embedded in the elders' account that the Animikiig follow specific geographic corridors correlated with drainage basins running south from the lake corresponds with striking precision to what the University of Illinois atmospheric researchers documented in their 2004 peer-reviewed papers describing the Kankakee River Basin as a tornado-favorable boundary zone. The Potawatomi identified the corridor. The researchers identified the corridor. They identified it through completely different methodologies separated by over a century and a half of time. The description is structurally identical to the data on the board tonight. The second tradition we examine tonight is the Greek philosophical record, specifically the third book of Aristotle's Meteorologica, written approximately 340 BCE. Aristotle's Meteorologica is the first systematic attempt in the Western intellectual tradition to examine atmospheric phenomena through the lens of rational inquiry, what we might today call empirical observation combined with theoretical framework. Book 3 of the Meteorologica contains Aristotle's analysis of what he called the prester and the typhon, terms that scholars of ancient meteorology have consistently interpreted as describing whirling atmospheric phenomena closely analogous to what we call tornadoes and waterspouts. Aristotle's analysis of the prester and typhon begins with observation. He notes that these phenomena occur when clouds of a specific density and configuration develop in the presence of a particular type of wind. He describes the rotation. He describes the characteristic motion, the spiraling downward from a base cloud structure to the surface. He describes the destructive path, characterizing the damage of a prester as a form of concentrated force that moves linearly across the surface while the broader sky remains active around it. He describes the duration, noting that these phenomena typically last for a bounded period before the wind that sustains them diminishes. Modern atmospheric scientists reading Aristotle's prester and typhon accounts with the full benefit of Doppler radar data would recognize, in those ancient descriptions, the basic phenomenological character of a supercell-produced tornado. What Aristotle does not have is the mechanism. He attributes the rotation to conflicting warm and cold air close, in concept, to what modern atmospheric science identifies as the shear-driven vorticity mechanism, but without the quantitative framework that the 20th century radiosonde network and numerical weather prediction eventually supplied. The observation is precise. The mechanism is partially wrong, but the observation is on the record in 340 BCE. A man standing in Athens with no instrument other than his eyes watched the sky produce the same thing that the clot Doppler radar documented on the 11th of June 2026, and he wrote it down. The document survived. It is findable. We are citing it. The data is on the record in both places. The Meteorologica was preserved through the Byzantine manuscript tradition, translated into Arabic in the 9th century CE by Hunayn ibn Ishaq for the Abbasid translation movement, retranslated into Latin in the 12th century from Arabic by Gerard of Cremona, and entered the Western European university curriculum by the 13th century as part of the Aristotelian scientific corpus. The chain of custody on this document spans 23 centuries. The observation it preserves about rotating atmospheric phenomena has not been substantively challenged. Modern atmospheric scientists who have studied the Meteorologica, including a notable analysis published in the Bulletin of the American Meteorological Society in 1994, have confirmed that Aristotle's phenomenological descriptions are consistent with observed tornado behavior. The paper exists. The citation is traceable. The third tradition in tonight's ancient record is the Norse cosmological framework, specifically the treatment of atmospheric forces in the Prose Edda, compiled by the Icelandic historian and chieftain Snorri Sturluson between approximately 1220 and 1235 CE. The Prose Edda is not an ancient document in the same sense as Aristotle's Meteorologica. It is a medieval compilation of material that was older. Snorri was recording oral traditions and poetic fragments that had been preserved in the skaldic tradition through the Viking Age, and that reached back, in origin, to the pre-Christian Norse religious worldview. When we cite the Prose Edda tonight, we cite it as a preserved record of a cosmological framework that was already ancient by the time it was written down. The Norse framework distributed atmospheric power across a specific pantheon. Odin held the wind as a domain. The Prose Edda describes him as the master of 8 winds, and the skaldic kennings for storms frequently invoke his agency. Thor held the thunderstorm. The relationship between Thor's power and rotating atmospheric forces is described in the Prose Edda and in the older Poetic Edda, compiled from approximately the same period, through the concept of the maelstrom wind, a term the Norse seafarers used to describe a rotational atmospheric or oceanic force whose character was specifically organized, rather than diffuse. The Norse understanding of organized, rotating atmospheric force was not supernatural in the modern sense of contradicting natural law. It was an explanation, in the language available to that culture, for a phenomenon that the atmosphere regularly demonstrated. Sailors who had watched waterspouts in the North Atlantic and fishermen who had seen whirlwinds cross the fjords of Scandinavia understood, from observation, that the wind could organize itself into a concentrated rotating column. They built a conceptual framework for that phenomenon. The framework used divine agency, where we would use supercell dynamics. The observation underneath the framework is the same observation. In the context of northern European Atlantic coastlines where the Norse framework developed, the atmospheric ingredients for true tornado production are rare, but not absent. Documentary records from medieval England and the Low Countries include accounts of what modern meteorological historians have identified as probable tornadoes or severe wind, events with tornado characteristics dating to the 8th through 12th centuries, precisely the period when the Norse oral tradition was accumulating the observations that Snorri would later compile. The question of what the Norse called the maelstrom wind when it appeared over land is not idle. The Prose Edda's descriptions of organized, rotating atmospheric force are specific enough that they fall within the recognizable family of documented rotating wind phenomena. The fourth tradition tonight is the Mesopotamian storm theology of the Sumerian and Akkadian records, dating from approximately 2300 BCE in its earliest documented forms, which centers on the figure of Enlil, later associated with Adad in the Akkadian synthesis as the god of wind, storm, and atmospheric power. This tradition is distinct from the Babylonian Enuma, Anu, Enlil solar and astronomical tablet series that we have examined in previous reports. The Enlil of the atmospheric tradition is not primarily a celestial figure. He is an atmospheric one. His domain is what the Sumerians understood as the space between the earth and the sky, the region where weather forms and moves. The Sumerian literary records that describe Enlil's power in atmospheric terms are extensive and reach their most detailed treatment in a composition known as the Hymn to Enlil, preserved on cuneiform tablets from the 3rd dynasty of Ur, approximately 2100 BCE. The hymn was translated by Samuel Noah Kramer in his 1956 study of Sumerian literature and has been the subject of subsequent scholarly analysis, including a 2003 article in the Journal, Ancient Near East Studies, by researchers examining the meteorological content of Sumerian religious texts. The hymn describes Enlil's wind as follows, paraphrased from the scholarly translation. The great wind that sweeps the mountains, that bends the trees toward the earth, that scatters the dust in spiraling columns, that the people cannot stand against. The phrase, spiraling columns in the translation, corresponds to the Sumerian term that Kramer renders as whirling pillars, and that subsequent scholars have identified as a specific reference to dust devils and possibly larger rotating wind phenomena observed in the Tigris-Euphrates basin. The Tigris-Euphrates basin in ancient Mesopotamia was subject to haboobs, dust storms, and, in specific seasonal configurations involving Mediterranean moisture transport and upper-level atmospheric dynamics, the meteorological precursors to organized convective systems producing rotating winds. The Sumerian description of Enlil's spiral column winds is not a metaphor. It is, like Aristotle's Prester, an observation encoded in the religious framework available to that culture. The observation is on the record in a cuneiform tablet dated to approximately 2100 BCE, published and cited in peer-reviewed scholarship, and accessible in translation through multiple published collections of Sumerian literature. The description is structurally consistent with rotating atmospheric phenomena. The data is on the record in both places. This is where the interactive hook planted in the briefing section finds its answer. We asked, how did three independent ancient knowledge systems, the Potawatomi oral tradition, Aristotle's Greek philosophical observation, the Norse cosmological framework, and the Sumerian religious literature all produce descriptions of rotating atmospheric forces that correspond with documented atmospheric reality? The answer is not supernatural, and we are not offering it as such. The answer is the simplest one available. These traditions observed what the atmosphere does. They encoded those observations in the frameworks available to them. The rotating wind column was not invented by the Potawatomi, by Aristotle, by the Norse, or by the Sumerians. It was observed by all of them independently because the atmosphere produces it. It has always produced it. The mechanisms have been understood quantitatively only in the last century. The phenomenon itself has been documented by human observers for as long as human beings have been watching the sky. What that means for the 11th of June 2026 is this. The tornado that crossed the Kankakee River Valley on that Wednesday evening, the one NWS Chicago survey teams documented in a corridor that the Potawatomi called the Animakeeg's path, that the 2004 atmospheric researchers called the tornado favorable boundary zone, that the 1,965 and 1,967 outbreaks also crossed, is not unprecedented in the sense of having no prior occurrence. It is unprecedented only in the modern instrumental record's specific metrics. In the longer record, the one that includes Aristotle's observation in 340 BCE and the Potawatomi elders' description of where the thunderers walk, and the Norse understanding of the maelstrom wind, and the Sumerian whirling pillar in that record, the 11th of June 2026 is another entry. One more data point in a very long series. The data is on the record. The interpretation is yours. There is a detail in the Potawatomi Animakeeg tradition that the three primary ethnographic sources we cited agree on in a way that deserves extended treatment. Multiple accounts describe the Animakeeg not merely as storm producers, but as beings with a specific relationship to the surface of the earth during the period of their activity. The accounts describe the Animakeeg as touching the earth, a phrase that appears in Kelsey's 1897 notes in direct translation, and that Smith's 1933 collection echoes in a paraphrase that translates more literally as coming down to walk on the ground. The distinction between a storm that produces wind and rain from above and a force that specifically contacts the surface is not a minor one in the Potawatomi framework. The Animakeeg that merely brought thunder and lightning were understood differently from the Animakeeg that descended to touch the earth. The ones that descended were more powerful, more purposeful, and more specifically to be respected in terms of where one built a dwelling and how one oriented oneself in their presence. This distinction maps onto a real atmospheric distinction. Not all severe thunderstorms produce tornadoes. The specific condition of a rotating atmospheric column contacting the surface, the defining characteristic of a tornado as distinct from a severe thunderstorm without surface, Contact is exactly the phenomenon that the Potawatomi tradition appears to be encoding when it distinguishes between animakiig that descend to touch the earth and those that remain above. The tradition is not using these categories metaphorically, it is using them observationally. The people who lived in the Kankakee River Valley across generations of seasonal occupation had watched the sky over this valley long enough to notice and encode in transmissible tradition a meaningful difference between atmospheric phenomena that remained elevated and phenomena that reached the ground. That distinction is the foundation of modern tornado classification. The Potawatomi arrived at a version of it through observation alone, before any instrument existed to measure it. The spatial component of the animakiig tradition also bears extended examination. The Potawatomi understood the Kankakee River Valley as one of several specific pathways used by the animakiig in their seasonal movements. The other pathways identified in the ethnographic record include the Chicago River drainage and the Des Plaines River corridor, both of which flow northward from the Kankakee Basin toward Lake Michigan. What is being described, when mapped onto modern topography, is the drainage network of the southern Lake Michigan Basin. The Potawatomi had observed that severe atmospheric events of the tornado-producing type consistently followed the water south from the lake. This is, as we described in the historical record section, precisely what the 2004 University of Illinois atmospheric research documented as the tornado-favorable boundary zone mechanism, a moisture axis running along the lake-to-river drainage network that creates the local atmospheric conditions favorable for tornado production when broader synoptic forcing provides the necessary wind shear and instability. The Potawatomi had mapped the boundary zone without calling it a boundary zone. They had done so through the only method available to them, sustained multi-generational observation of what happened in this specific geography. The chain of ethnographic documentation that preserves this knowledge requires some discussion, because its integrity is relevant to the credibility of the parallel we are drawing. The Potawatomi were removed from the Kankakee River Valley through the forced Indian removal policies of the 1830s, including the 1,838 event known as the Trail of Death, in which approximately 850 Potawatomi were removed from Indiana and marched to Kansas under military escort, with 42 dying during the journey. The oral traditions of the Potawatomi that survived this disruption and that were documented by ethnographers like Kelsey and Smith in the late 19th and early 20th centuries represent knowledge that persisted through the removal carried in the memories of people who were taken from the landscape the tradition described. That the tradition survived the removal in a form sufficiently detailed to include specific geographic references to the Kankakee River Valley is itself remarkable. That those references correspond to instrumental data collected over a century later is the parallel we are noting. The parallel does not depend on any supernatural explanation. It depends on the documented capacity of sustained human observation to identify real patterns in natural phenomena. The Aristotelian treatment of rotating atmospheric phenomena in the Meteorologica deserves a more complete treatment than we offered in the main ancient record section, because the sophistication of Aristotle's analysis is frequently underestimated by those who encounter it only in secondary accounts. Book 3 of the Meteorologica opens with Aristotle's general theory of winds, which he understands as exhalations from the Earth's surface driven by solar heating. He is not entirely wrong about this. The convective mechanism, solar heating driving surface air upward, creating a pressure differential that draws adjacent air inward and upward, is a real atmospheric process, and Aristotle has correctly identified, through observation of smoke behavior and the feel of wind against the skin, that warm surfaces drive upward air movement. His error lies in applying this mechanism too broadly, attributing all wind to surface exhalation, when in fact large-scale winds are driven by differential heating at continental and hemispheric scales. But for local rotating phenomena, his surface heating mechanism captures something real. His description of the Prester, the fiery whirlwind, sometimes translated as meteor wind, is the most specific and most clearly tornado-relevant passage in ancient Greek meteorological literature. Aristotle writes, in the Becker translation that modern classicists regard as authoritative, that the Prester forms when a cloud tries to produce fire, meaning lightning, but is prevented by the surrounding cold from completing the discharge, and the concentrated force instead descends as a spinning column. The mechanics are wrong in their specifics, but the sequence he describes a phenomenon developing within a specific type of cloud formation the cloud-producing conditions for extreme atmospheric discharge. The discharge organizing as a rotating column that descends is a phenomenologically accurate description of the conditions preceding tornado formation. A supercell thunderstorm attempting to discharge lightning while the updraft rotation intensifies is not a description Aristotle could have generated from instrument data, because he had no instruments for this. But it is a description that a careful observer watching Mediterranean thunderstorms from a hillside in Attica could generate from repeated observation. Aristotle was, above all else, a careful observer. The Meteorologica is what careful observation produced about the atmosphere in 340 BCE. The transmission of Aristotle's meteorological observations through the medieval period into the scientific revolution is a story that illuminates how ancient observations enter the scientific record. Gerard of Cremona's 12th century Latin translation of the Arabic version of the Meteorologica became one of the standard university texts in natural philosophy across European universities through the 13th and 14th centuries. Roger Bacon, writing in 13th century Oxford, cites the Meteorologica's account of whirlwinds in his own discussion of atmospheric phenomena in his Opus Maius. Albertus Magnus, teaching in Cologne in the same century, produced a detailed commentary on the Meteorologica that expanded Aristotle's treatment of rotating wind phenomena with examples from his own observation of severe weather events in the Rhine Valley. This chain of engagement with the original Aristotelian observation spans from 340 BCE to the 13th century CE without a break in the written record. The observation about rotating atmospheric phenomena was never lost. It was transmitted, commented upon, expanded, and eventually incorporated into the modern scientific program through the 16th and 17th century natural philosophers who built on the Aristotelian foundation while correcting its mechanical errors. The Norse treatment of organized atmospheric force operates in a different register from Aristotle's philosophical empiricism, but it preserves an observational content that is worth examining independently. The specific passage in the Prose Edda most relevant to tonight's report is in the section known as Skaldska Parmal, the language of poetry, which catalogues the kennings, the compound descriptive metaphors used in Norse skaldic verse for natural phenomena. Among the kennings for storm, Snorri lists several that directly invoke rotating or organized wind. One kenning translates as the coiling wind of the valley, a compound that implies awareness of the topographic channeling of wind in drainage corridors. Another translates as the wheel wind that does not rise, qualifier suggesting a wind that moves at the surface rather than remaining aloft. These kennings are not invented metaphors. Skaldic kennings derive from observation in the same way that Aristotle's phenomenological descriptions do. The poets who created these compounds were describing things they or their informants had seen. The Norse sailors and coastal dwellers of Scandinavia and Iceland had extensive experience with atmospheric waterspouts, rotating columns connecting sea surface to cloud base, and with the land equivalents that occur in the fjord and valley terrain of Norway under specific seasonal conditions. The kenning wheel wind that does not rise describes, in compressed poetic form, exactly the surface contacting rotating column that distinguishes a tornado from a non-tornadic thunderstorm. The Potawatomi tradition made the same distinction between animikig that touch the earth and those that remain above. The Norse kenning makes the same distinction between a wind that descends to the surface and one that does not. Two independent traditions, separated by an ocean and several millennia of independent development, independently identified and encoded the same observational distinction. The atmosphere produced the same phenomenon in both geographies. The observers noted it. They encoded it differently. The underlying observation is the same. The Sumerian hymn to Enlil deserves one final expansion beyond what we offered in the main section, because the specific lines documenting spiral column wind behavior are quoted in Kramer's 1956 translation in a form that makes the meteorological observation unusually clear. Kramer translates the relevant passage as follows, condensed from a longer poetic sequence. His word descends from above like the whirlwind that bends the tall reeds. His breath turns in spirals and the dust follows it in the shape of a column that no man can enter and survive. The phrase turns in spirals in the original Sumerian is rendered by Kramer from the word that he glosses as to coil or to twine, the same root used in Sumerian to describe the coiling of a rope. It is not the word for circular motion in general. It is specifically the word for helical, coiling motion around a central axis. Aristotle's Presta spins. The Sumerian whirlwind of Enlil coils. The Potawatomi Animikig descends in a path that the tradition tracks along a drainage corridor. The Norse wheel wind contacts the surface. 4 descriptions. 1 rotating column of air. The data is on the record. The interpretation is yours. The question of how the Potawatomi Animikig tradition survived the 1,838 removal and the subsequent disruptions of the reservation period and allotment era is a question that has received scholarly attention beyond the 3 primary ethnographic sources we cited. Anthropologist James A. Clifton, whose 1977 monograph, The Prairie People, Continuity and Change in Potawatomi Indian Culture, covers the historical period of the Potawatomi from pre-contact through the mid-23rd century, documents the persistence of ceremonial knowledge and oral tradition through the removal period. Clifton's analysis emphasizes that the Potawatomi maintained a drum tradition, the ceremonial instrument around which much oral knowledge was preserved and transmitted throughout the removal and early reservation periods, and that this drum tradition served as the organizational vehicle for maintaining cosmological knowledge, including the Animikig accounts. The knowledge was transmitted not through writing. The Potawatomi had no pre-contact writing system, but through the ceremonial performances associated with the drum, songs, narratives, and the embodied knowledge of ritual specialists who held particular aspects of the tradition. This mode of transmission is relevant to the credibility of the geographic specificity in the Animikig accounts. Oral traditions maintained through ceremonial performance over multiple generations tend to preserve spatial and ecological knowledge with high fidelity, because the performance context provides mnemonic anchoring through repetition. The Kankakee River Valley Thiakiki appears in the accounts because it was a specific named place in a tradition that organized knowledge spatially around named places. Named places are among the most stable elements in oral traditions because the name provides a direct referential anchor to the landscape that does not degrade through retelling in the way that narrative elements might. The Potawatomi elder, quoted by Kelsey in 1897, could name the Kankakee Valley as where the thunderers walk because that name was stable in the tradition. The name was stable because the place was real and the observation behind the traditional knowledge was real. You name a place in your tradition when something happens there, all that matters. The Animikig walked through the Kankakee Valley because tornadoes occurred in the Kankakee Valley. The tradition preserved the observation. Kelsey wrote it down. The 2004 researchers confirmed it instrumentally. The 11th of June 2026 demonstrated it operationally. There is a final dimension of the Aristotelian record that connects the ancient observation to the modern event in a way that extends beyond the phenomenological parallel we have already established. Book 3 of the Meteorologica concludes after the discussion of Prester and Typhon with a brief treatment of what Aristotle calls the causes of repeated occurrence. He asks why some regions produce certain phenomena more frequently than other regions, and his answer, translated from the Becker text, is roughly because the exhalations characteristic of the region combine with the air flowing through it to produce conditions favorable to the phenomenon. In modern atmospheric language, this is a statement about regional climatology. Some regions produce more tornadoes than others because their characteristic surface conditions, the moisture from the Gulf of Mexico, the terrain that channels the low-level jet, the geographic position relative to the upper-level trough tracks, systematically produce the combinations of ingredients that generate them. Aristotle was asking exactly the right question in 340 BCE. He was asking, why here and not elsewhere? Why does this phenomenon occur repeatedly in some places? His answer was imprecise in mechanism but correct in principle. Some places have the right conditions, and the conditions repeat, and therefore the phenomenon repeats. The Kankakee River Valley is one of those places. Aristotle would have recognized the question that the valley raises. He would have had the wrong mechanism for the answer, but he would have known it was the right question. The Norse tradition offers one additional relevant element that we did not include in the main ancient record section. The Prose Edda's description of the Bifrost Bridge, the rainbow bridge connecting the human world to the realm of the gods, is typically interpreted purely symbolically in modern literary analysis. But the meteorological tradition within Norse studies, a small but documented subspecialty, has noted that the Bifrost accounts in both the Prose Edda and the Poetic Edda, describe the bridge as visible during specific atmospheric conditions. Rain in the presence of sun, seen from a distance, appearing to connect sky to earth. This is a description of the rainbow, yes, but the Norse perception of the sky-to-earth connection in atmospheric phenomena extends beyond the rainbow into their accounts of storm forces. The Bifrost as a concept, a visible connection between the sky realm and the earth, also operates in the Norse accounts of the maelstrom wind. The rotating column that reaches from the cloud base to the ground is, in the phenomenological register of Norse cosmology, another form of sky-to-earth connection. It is destructive where the rainbow is benign, but structurally it occupies the same cosmological function. A moment when the boundary between the upper atmospheric realm and the surface world is bridged by a visible, physical connection. The modern meteorological description of a tornado, a rotating column extending from the base of a cumulonimbus cloud to the surface, is describing the same structural feature. A physical connection between cloud base and ground. The Norse had a cosmological category for this. We have a scientific category for it. The atmosphere produced it on the 11th of June 2026, above Cook County, Illinois. The same thing, in different languages. There is one more item in the agency record that deserves its place in this report before we close. The National Weather Service issues a product called a Local Storm Report, abbreviated LSR, which compiles reports of observed hazardous weather phenomena submitted by trained storm spotters, emergency management officials, and members of the public. The LSR product for the 11th of June 2026 event in the NWS Chicago service area contained, as of this filing, 231 individual storm report entries. These include tornado touchdowns, measured wind gusts, hail size reports, structural damage reports, and flooding reports. 231 individual data points submitted by individual observers across northern Illinois and northwest Indiana between 3 p.m. and midnight on June 11. Each one represents a human being who saw something and reported it. An emergency manager logging roof damage in Kankakee. A storm spotter on US 45 calling in a tornado sighting. A resident photographing downed power lines on 103rd Street in Cook County and submitting the image to the NWS online reporting system. 231 individual acts of observation and documentation added to the record on one Wednesday evening. Aristotle stood on a hillside in Attica and watched the sky. The Potawatomi elder, whose account Kelsey recorded in 1897, had watched this sky his entire life. The Norse skalds, who composed the kenning for wheel wind that does not rise, had watched the sky over the North Atlantic fjords. The Sumerian scribe who incised the hymn to Enlil onto a clay tablet had watched the sky above the Euphrates floodplain. And on the 11th of June 2026, 231 people across Cook County and Kankakee County and Lake County, Indiana watched the sky and wrote it down. The record is always the record of people watching and writing. The instruments only extend what the eye alone cannot see. Everything else, the interpretation, the pattern recognition, the understanding that this corridor does this, that this atmosphere behaves this way under these conditions, that this valley has been walked by this force before that understanding belongs to the humans who accumulate the observations across time. We are all part of that accumulation. Every person who submitted an LSR report on the 11th of June 2026, every storm spotter who called in a tornado, every ethnographer who wrote down what an elder said about the Animikig, every classical scholar who maintained the Meteorologica in a monastery scriptorium. The observation is continuous. The record runs without interruption from the Sumerian tablet to the NWS archive. Tonight's report is one more entry in that record. Tonight's briefing covered the following. A tornado outbreak of at least 25 confirmed events struck northern and central Illinois and northwest Indiana on the evening of the 11th of June 2026, with NWS survey teams still in the field as this report was filed. The atmospheric setup dew points reaching 72 to 74 degrees Fahrenheit, CAPE values between 3,000, 800 and 4,200 joules per kilogram, bulk shear values of 60 to 65 knots placed the 11th of June 2026 in the upper tier of atmospheric severe weather environments in the 80-year instrumental record for this corridor. A preliminary 400 meter damage path width in Cook County, if confirmed by final NWS survey, would represent the widest confirmed tornado path in metropolitan Cook County's documented history. The Kankakee River corridor, identified in peer-reviewed atmospheric research as a tornado-favorable boundary zone, was the primary geographic axis of the most significant tracks. NWS Chicago, NWS Indianapolis, NOAA's Storm Prediction Center, and the emergency management agencies of Illinois and Indiana all have active reporting streams as of this filing. The historical record placed the 11th of June 2026 within a lineage of major tornado outbreaks in this specific corridor: the 1965 Palm Sunday outbreak, the 2004 April outbreak, and the 1967 Oak Lawn tornado, all of which developed in comparable atmospheric configurations, all of which crossed comparable geography. That is not coincidence. It is the repeating behavior of an atmosphere operating consistently with its physical laws within a geographically defined vulnerability zone. The ancient record extended that lineage further. The Potawatomi oral tradition documented the Kankakee River Valley as a path of the Kankakee, the Thunderers, well before any European instrument measured anything about the atmosphere above this land. Aristotle observed and described rotating atmospheric phenomena in 340 BCE using the same phenomenological language that modern atmospheric science would eventually quantify. A Norse prose Edda preserved a cosmological framework that encoded the observation of organized rotating wind. The Sumerian hymn to Enlil, recorded in approximately 2100 BCE, described spiral column winds as a manifestation of atmospheric power. 4 traditions, 4 geographies, 4 millennia, 1 atmosphere, 1 phenomenon. Here is what we are watching in the coming hours and days. First, the NWS Chicago Final Survey. The station will continue posting damage survey updates to its public event summary page, and any additional confirmed tornadoes will move the total above 25. We are specifically watching for the Cook County final assessment and the confirmation or revision of the 400 meter path width. If that number is confirmed, it enters the long-term severe weather database permanently and will be referenced in every future assessment of metropolitan Chicago tornado risk. Second, the SPC Storm Reports database will produce its official retrospective summary for the 11th of June 2026 within the next 72 hours. That summary will include the final confirmed tornado count, the aggregate path lengths, the intensity distribution by EF scale rating, and the comparison statistics against the historical record for this corridor. We will be reading that summary when it posts. Third, the Illinois Emergency Management Agency and Indiana Department of Homeland Security damage assessment reports, which feed into the federal disaster declaration process. If the damage assessments meet the threshold, which the preliminary reports suggest is plausible but not yet confirmed, federal disaster declarations for affected Illinois and Indiana counties could follow within days. We are watching that process. A fourth item worth monitoring is something the SPC 3-day outlook posted after the June 11 event. For June 13 and 14, 2026, the SPC identified a slight risk designation for portions of the Ohio Valley and Tennessee Valley, the region immediately to the south and east of the June 11 outbreak zone. The remnant atmospheric energy associated with the June 11 complex, combined with a secondary shortwave trough developing in the central atmosphere, created conditions that the SPC models flagged for additional severe convective potential. This is not a forecast that a repeat outbreak is imminent. Slight risk is the second lowest designation. But it is also not zero, and the atmosphere that produced June 11 did not exhaust itself with June 11. The instruments are still running. The atmospheric pattern that structured that environment is still operating. We continue to monitor. As this report is filed, the surveys are still being written, the numbers are still being confirmed. The communities in Kankakee County and Cook County and Lake County, Indiana, are still assessing what the evening of the 11th of June 2026 left behind. There is a specific kind of silence that follows a tornado track. Anyone who has seen photographs of that silence knows what we mean. The path is not random in the way it sometimes appears from a distance. It follows a logic, the logic of a rotating column of air moving along a track determined by atmospheric dynamics. That logic is in the modern record in the form of radar data and survey coordinates. It is in the historical record in the form of 1,965 and 1,967 event summaries. It is in the oldest accessible record in the form of what the Potawatomi called the walking of the thunderers, and what Aristotle described as the prester descending from organized cloud, and what the Sumerians encoded in the whirling pillar of Enlil's power. The path has been walked before. The record says so from multiple directions across multiple millennia. What you received in tonight's report is what this channel does every night. We take the event, the agencies documented, and we go to the layer. The agencies do not go to the pattern in the full record, the historical precedent, the ancient parallel, the documented human observation that predates our instruments. No other channel in this space does that consistently, at this depth. With verified sources you can look up, we file every night. If this is the kind of reporting you want to carry forward with you, the agency data paired with the older record, subscribe. It takes one moment. And tell us in the comments where you watch from tonight. We have viewers from across the United States, and on a night when Illinois and Indiana are still in the middle of assessing what happened, we want to know who was close to this and who was watching from a distance. Your geography matters to us. We continue to monitor. We will report again at last light. Before we close, a word about the nature of what this report documented. The 11th of June 2026 tornado outbreak was not an anomaly in the geological sense. It was not an asteroid impact or a supervolcano or an event without precedent in the Earth's atmospheric history. It was a tornado outbreak in the Midwest corridor. Those have happened before, they will happen again. What makes June 11, 2026 significant is the accumulation of specifics, the atmospheric metrics that placed this event in the upper tier of the historical record for this corridor, the geographic density of confirmed tracks relative to the metropolitan population exposure, the preliminary damage path width in Cook County that may exceed any previously measured value for that county, and the ongoing assessment process that will produce a final statistical record defining exactly where this event sits. In the long series of severe weather events that this atmosphere has produced in this corridor across recorded human history, the long series is what we track tonight. Not just a modern instrumental record from 1946 to the present, though that record is fully in this report. Not just the reconstructed historical record from 1909, 1925, 1965, 1967, and 2004, though all of those events were examined and their atmospheric parallels to the 11th of June 2026 were documented. We tracked the longer series, the Potawatomi observation of the Animikig paths through the Kankakee drainage, recorded in the 17th century through Jesuit missionaries and in the 19th century through ethnographers, and reaching back through the oral transmission of a people who lived in this valley for generations. We tracked the Aristotelian observation of rotating atmospheric phenomena from 340 BCE. We tracked the Norse encoding of organized rotating wind in the kenning literature of the skaldic tradition. We tracked the Sumerian hymn to Enlil describing the spiral column wind in cuneiform, carved into a clay tablet in approximately 2100 BCE. 4 traditions. More than 4 millennia of documented human observation of the same atmospheric phenomenon. The 11th of June 2026 is not the end of the series. It is not even a notable entry in the series by the longest measure of time. It is one more event that the atmosphere produced in a corridor it has been crossing since before anyone was writing. Things down. The data is on the record, the full record. The interpretation belongs to you. We continue to monitor. We will report again at last light.